This is Geometry, Chapter 3, Section 2, in which we will continue studying parallel lines and the angles that are formed with those. Whenever we have parallel lines, remember those are coplanar lines that don't intersect. And those lines are cut by a transversal, some line that intersects both of them in different places. If you recall, we got, with two parallel lines and a transversal, we got 8 angles on our last lesson. When the lines are parallel, we have special relationships in play. And this is another one of those things where you're going to have to look at what kind of relationship there is to decide what to do with the problem. Okay, you're going to have to analyze the situation before you know what to do. The first relationship we're going to look at is corresponding angles. Remember, those are the ones that are in the same basic spot in the intersection, the upper left corner or the lower right corner or something like that. So our first postulate of the chapter, postulate 3.1, which is called the corresponding angles postulate. If we have two parallel lines cut by a transversal, then the corresponding angles are congruent. Each pair of them turns out to be congruent, which is a really useful fact. So consider this beautiful picture. We have two parallel lines, and they tell us the value of angle 8. Angle 8 is 105 degrees. Our job is to figure out angles 5 and 3, and then tell which postulates or theorems we used. So we're not doing a full proof here, we're just kind of thinking about how a proof would work, telling how we got to our answer, but we're not having to do a formal full proof. Now, if I want to find out about angle 5 and 3 with angle 8, there's not a whole lot I can do directly. But the corresponding angle postulate tells me that 8 will be congruent to 4 because they're corresponding. They're in the same basic place. Knowing then that 8 is equal to 4, I also know that 4 is equal to 5 from the vertical angle theorem from last chapter. I believe the number was 2.8, but I could be wrong about the number. The name, though, the vertical angle theorem, is the correct name for it. So since 8 is equal to 4 and 4 is equal to 5, indirectly I'm using the transitive property. They didn't ask me to state property, so I'm not going to on the screen here, but just in my mind I'm thinking transitive. 8 equals 4, 4 equals 5, that means 8 equals 5. And since 8 is 105 degrees, so is 5. Now that I know 5, I can find 3. 5 and 3 are supplementary. That's what the linear pair theorem told us. I believe that one was theorem 2.3, the supplements theorem was the other name we had for it. So since this is 105 at angle 5, that leaves 75 for angle 3. Combining what we learned last chapter with the new ideas. These things are going to keep building on each other. That's why I told you not to throw away your notes, because you're going to need them as we continue forward. Now there are some more theorems for some of the other relationships. And these are theorems, we can prove those if we need to. The first one, theorem 3.1, deals with alternate interior angles. If two parallel lines are cut by a transversal, then the alternate interior angles are congruent. So I'm going to jump back a page to my picture here. In this case, we would be talking about angle 5 and angle 8 would be congruent by alternate interior angles. Angle 6 and angle 7 would also be congruent. If we needed to prove the alternate interior angles theorem, you could do it just like we got to angle 5. Angle 8 corresponds with 4. 4 is vertical with 5, and then transitive. So that's how the alternate interior angles theorem works. Just for the sake of while we're thinking about it, I'm going to jump ahead to theorem 3.3. Alternate exterior angles also turn out to be congruent. So on here we would be saying 1 is congruent to 3. 2 is congruent to 4. And the proof of that would be very similar to the proof for alternate interiors. Now I'll jump back and pick up 3.2, consecutive interior angles. Remember, some books are going to call those same side interiors. You'll probably hear me say that a few times because I'm used to that terminology. The consecutive interior angles theorem tells us if parallel lines are cut by a transversal, then the consecutive interior angles are supplementary. Okay, they're not congruent. If you're dealing with consecutive interiors, same side interiors, those are supplementary. So 6 and 5 would be supplementary to each other. They're not equal. We don't have 5 as congruent to 6. We would have 5 plus 6 equals 180. And the same thing over here with 7 and 8. Now, for whatever reason they discriminate against consecutive exterior angles, those are also supplementary. I've always thought there should be a theorem for it if there's a theorem for all the other ones, but nobody asked me. So let's consider this problem. We have line A parallel to line B. Line C is a transversal, making our 8 angles that we numbered this time in this particular order. And we keep changing the order so you don't get it into your mind that 1 is always congruent to 5 or something like that. They might be, they might not be. It just kind of depends on where things are. If we know angle 2 and we know angle 6, we need to figure out what is the relationship between those. 2 and 6, they're both exterior angles, and they're on opposite sides of the transversal, so these are alternate exteriors. And our theorem from the previous page, theorem 3.3, says that alternate exterior angles are congruent. Okay, that's the kind of thinking you're going to have to go through. What is the relationship between the angles? Which theorem applies? So we decided that they're congruent. That means they're equal to each other, so that gives me the equation to use. Well, solving for x, we'll subtract the 4x over, add the 13, and we find out x is 20. And that's all we have to find for this one, because that's all they said, find x. If they said find angle 6, then we would have to plug the 20 back in. Okay. One more idea here with transversals and parallel lines is the perpendicular transversal theorem. Fancy name for something that's pretty much common sense. If a line is perpendicular to one line out of a parallel set, then it's going to be perpendicular to the other lines in a parallel set. If you look at the lines on your notebook paper, all those lines going across the page are parallel. the margin line that goes down the left side is perpendicular to the top one. Well, it's perpendicular to the next, and the next, and the next, and the next, and the next. And it continues being perpendicular all the way down. Okay, that's what this theorem is saying. If you know it's perpendicular to one of the lines, it's going to be perpendicular to the rest of them, provided they're all parallel. Okay. So the big ideas here are knowing the relationships between the angles, alternate interiors, alternate exteriors, consecutive interiors, correspondings, deciding whether that means they are congruent to one another or whether that means that they are supplementary with each other, and then writing the appropriate equation to solve. If you had questions along the way, hopefully you wrote those down, bring them in with you, and we will see you in class.